Alright then, welcome back everyone. So let's solve this question. Don't try to count. Let me read out the question for you. Given a string x of length n and string s of length m, so we are given two strings consisting of lowercase Latin letters, so like A to Z only. You can apply any number of operations to string x. And what is that operation? In one operation, you append the current value of x to the end of string x. So basically, if you have x, like for example, if you have ABA, then it like you just pick ABA and assign back to it, so it becomes ABA. Okay, if you perform one more operation here, note that x will change after this. Okay, so the one operation is take x, assign x at the end of it, and then store again in the value of x. So if you apply one more operation, this entire thing will be taken and appended back, right? So this entire thing will be taken and appended back. Fine. After what minimum number of operations s will appear in x as a substring? A substring of a string is defined as a contiguous segment of it. Okay, so this question is asking like you are given two strings, one is x and one is s, one's length is n, another length is m, and you have an operation that you can do on x. You can make x xx, then of course store it back to x, then make it like take that xx and again append xx to back of it. Similarly, so you can make basically you have one operation at your disposal, take a string and append it at the back of it. Out of what minimum number of operations this will appear at x as a substring? Fine, so that's the question. Input first line is the single integer t, test cases, no issues with that. First line of each test case contains two numbers n and m. Okay, so n is the length of x and m is the length of s. Fine. Second line of each test case consists of string x of length n and string s of length m. Okay, maybe the inputs are too much, I might forget what those are, so let me just first take the inputs and we can understand the question. So what is it? The first line of input contains a single integer t, okay, test case is handled. The first line of each test case consists of two numbers n and m, so nm. I'll just take input quickly. Then second line contains string x. Okay, so see, I forgot m here. That's why if input is very big, I usually prefer taking it first. So string s and then string x, then string s. So right, so let me just confirm. First string x and then string s. Fine. And for each test case, output a single number, the minimum number of operations after which s will appear in x as a substring. If this is not possible, output -1. Cool. Output -1. So we have to output -1. Here you can see some examples. Let's just see examples here only. So you can see after some amount of operations, after like one operation, this a will become aa, and after one more operation, it will become aaa, and after one more operation, like again a will be implemented, and I guess after 3 operations, right? So 3 operations. Don't worry, we'll see one or two test cases in detail, so how they work. So yeah, basically after how many operations s will appear in x as a substring, print that, otherwise output -1 if it is not possible. Okay, if it is not possible, then output -1. So maybe in this case, I guess the fourth test case. So in the fourth test case, it's not possible. Okay, let's see. Let's try to analyze this question a bit. Now, this is an A-rated question. Again, you won't be having the problem tags when you encounter such type of questions in a contest, but you know this is an A-rated question. So firstly, you don't need to worry about very complicated logic. Now, if someone sees that minimum thing, he or she might think, okay, maybe I have to use DP or something like that, but no. Just look at the constraints. What are the constraints? N into m is less than equals to 25. That's what it is given, right? So maybe just let me just increase the font size. So n into m is less than 25 is given, right? And of course, basically greater than equals to 1 and less than equals to 25, right? Since it is an A-rated question, think in terms of brute force. Let's say you just want to check whether after some amount of operations. So what are operations again? So if you have initially x, after one operation it can become xx. After one more operation it can become xx, right? After one more operation, this xx is there, I'm going to append one more xx to the back of it. Similarly, after one more operation, this xx was there, I'll append one more to the back of it, right? So this is how operations work basically, right? So these are the constraints. Look at the constraints. So let's think about the worst possible case. So by the way, n is the length of x, right? So length of x is n and length of s is m. So let's think about the worst possible case. Like what is the worst possible scenario? So the worst possible scenario is n equals to 1 and m equals to 25. So basically x is very small. Let's say x is a only, and s is a basically 25 times, right? This is the worst possible case, right? So here you will have to do maximum number of operations. Specifically, how many number of operations? Let's see. So if n is 1, this is the worst possible case, right? Because here x is very small, and how much small? As small as it can get, one size. And S is as big as possible, as big as it is possible, like provided by the constraints, just 25. So what is the minimum number of operations here? Let's see. Now we know anyway, after some amount of operations, X will become part of S. So initially it would be A, okay? So then it would become, after one operation, it would become AA. Then after one more operation, let me just write the operation also. So after one operation, it becomes AA. Okay, sorry. After one operation, it becomes AA. After one more operation, AA will be there, and you can take this AA and append back to it, right? So this would be after two operations, it will become this. Then after three operations, we'll have this 4 times A, and I'm gonna append 4 more to behind. So basically, this will be 3 operations. Okay, and after, like, I will not write A now. I'll just write the sizes. So here it was size 2, it became size 4, it became size 8. Now the size will be 16. This size will be 16. Now still this S is not part of it, right? So S has to be part of X. And after one more operation, the size will become 32. So basically, after 4 operations, the size became 16, and after 5 operations, it became size 32. So this says you clearly, this was the worst possible case we considered. X was very small, S was very big, that you cannot have more than 5 operations, right? You cannot have more than 5 operations in the worst case. So why not just run a loop in which you apply 5 operations, right? Just try to see if even if after applying 5 operations, S is not becoming part of X. So what I'm trying to say is, try doing the operation 5 times, okay? Even after 5 operations, S is not part of X, then print -1, right? Simple as that. Like, even I guess they're saying what is the minimum of operation, right? So maybe if after applying operation ith time, maybe some time, you can just print that I, right? Simple. That is the idea, guys. There's nothing more to this question. So let's code it up very quickly. So how will you check whether S is part of S and all? So don't need to worry about it. You don't need to implement it actually. C++ provides utility for that. So let's just quickly code it. So you know you're bound on your operation, right? So you know the operation can start from 0. An operation is less than equals to 5, right? Operations plus plus. So maybe I'll just reduce it down here so you can see what we have done here. So yeah, so first need check, because it might happen, right? Initially only S can be part of X, so we may not need to apply any operation, right? So what I'm saying is you can have something like this, right? X can be something like AAA, and S can be just A. So here we don't need to apply any operation. S is anyway part of X, right? S is anyway part of X. So you can just do like this. So what do you want to see? Whether S is a substring of X, right? So if X dot find S not equals to string npos. So basically what this is, this find will try to actually look out for S in X. If it finds it, it's going to return the index of the first occurrence of S. Otherwise, it's going to return this constant, string npos. So this is basically -1 only. It's defined in the C++ header. This is actually, this is -1 only. So basically, when you try to find S in X, if it is not equal to -1, that is, you have found this string in X, what you can do is, you can just print after how many operations we got our answer. And anyway, we can break out of the loop. Right, otherwise you have to perform an operation. Which operation? So apply the operation x dot append x, right? Just apply an operation, basically apply operation, just append x to the back of it. Now if we break out of the loop, we need a way to check, right, whether S was found in X. So maybe I can just maintain a boolean variable. Initially it can be false, and if we found S in X, we can just make found equals to true. And here we can say if we didn't find S in X even after applying 5 operations, then we can just print -1, right? Fine. So that's that. This is the input. We can apply 5 operations, so we are gonna run this loop 5 number of times. So basically we are actually running this loop 6 number of times, right? So after applying operation 0, after applying operation 1, after applying operation 2, right? So we are going to run this loop after applying operation 1, 2, 3, 4, 5, so on and so forth, right? So when operation equals to 5, like in the worst case, we might have a string of size. Like, what is the worst case size of string? Okay, let's come back to that after a while. But this is the code basically. Right? We are applying maximum 5 times our operation. Let me just quickly run it and see whether it works. Yeah, let me just verify. 3, 1, 2, minus 1, 1, 0, 1, 3, 1, 0, 2, 5. Fine, huh? I guess it works. Let me just submit it, and then we can discuss time complexity here. Usually we don't discuss it, but because mostly they are order of n. But anyway, let's just submit it, and then we can discuss the time complexity. Okay, it got accepted. Now the code is fine. Now let's discuss the time complexity. What can be the time complexity here? So initially the string length will be n. We're talking about the worst case, right? Then it will become 2 into n, like the string length of x. Then it will become 2 into n. So basically I can write 4n, right? Then it will become 2 into 4n, basically 8n. Then 16n, and then finally 32n. It won't go more than that, right? So after a 0th iteration, basically, so this is iteration 0. At the 0th iteration, it is n. At the first iteration, it is 2 into n. At the stroke of second iteration, it's 4 into n. Stroke of third iteration, 8 into n. Stroke of fourth iteration, 16 into n. And stroke of fifth iteration, it's 30 into n. So I'll just write the index also. I'm just writing this because I'm assuming that beginners are watching this. So I equals to 0, I equals to 1. So this is basically ops, right? Ops 0, ops 1, ops 2, ops 3, ops 4, and ops 5, right? And at every iteration, how much work we are doing? Let's see. We are calling this find, right? We are just at every iteration. Anyway, we are doing this append operation. So this is one operation. It will cost this much time only. So this append will, if you have a string of length n, then append, we just append it to the end. So it costs order of n only. So it basically, the append's complexity is equal to number of characters in the string. Fine. So let me write the time also here. So the time here, anyway, we are doing n, then 2 and so forth. So this is same, n, 2 n. So we are not doing more than order of n work. That's what I'm saying. So at every junction, we are doing order of n work, order of n for this and this part. What is this part? What is the maximum worst case complexity of this part? We are trying to look out for s in x. So that will be, that finds complexity will be the string you're searching, order of n, into m, basically. The complexity you're searching, right? So okay, let me repeat myself again. So if you have a string of length n and you're searching a string of length m inside it, the time complexity will be n into m. Now on an average, the find will try that the time complexity stays close to n, but worst case n into m will be the one. So the total time complexity, you can think like this. It will be 32 into, because 32, or you have 5 iterations, right? So you have 5 iterations. So 5 into order of n into m. I didn't write 32 here. You can write maybe 32 also here. But 32 is a constant, so we can neglect it. So everything is a constant, so eventually the time complexity is just order of n into m. Fine. So how did this 32 came here? Because like the worst case, the string length is 32, right? So 32 into n into m, and into 5 because 5 iterations. But in asymptotic analysis, we can ignore all of this. So that's the time complexity. Space complexity, we are not using any extra space. So yeah, that's that. That's what I wanted to discuss. Thank you for watching. I'll see you in the next one.